Welcome back to STS. In this video, we're going to convert a repeating decimal to its equivalent fraction. We begin here with the 0 and 2 repeating. We know the 2 is repeating because we see the bar over the 2, and we know that's the only number repeating. So what we first have to do is set this thing equal to n. So here we have n is equal to the repeating decimal. And because it's only a single place value repeating, that means we just multiply n times 10 and the repeating decimal times 10. So I end up with 10n on the left hand side, and I end up with 2 and the 2 repeating on the right hand side. Remember that when you multiply by 10, you just move your decimal point one place to the right. Alright, at this point I'm going to subtract 10n minus n to give me 9n. And on the right hand side, these repeating decimals cancel out, leave me with just a 2. And then I'm going to solve for n, so I'm going to divide both sides by 9. So here I come out with n is equal to 2/9. Alright, let's do another example. In this example, let's have two place values repeating. So for this one, let's say we have 0 and 35 repeating. First step, as usual, is to set the original repeating decimal equal to a variable. So here I'm going to say n is equal to 0 and 35 repeating. And because I have two place values repeating, now I'm going to multiply each one of these terms by 100. So now I have 100n, and when I multiply this here by 100, I end up with 35 and 35 repeating. And just to be clear, let me go up here. 35 repeating is 35, 35, 35, 35, etc. off into infinity. If I multiply this by 100, that means the decimal point moves two places to the right. So the new number is 35 and the 35s repeating. That's how I come to this expression here. Now I do a subtraction. 100n minus n to give me 99. The repeating portion cancels out, and I'm left with 35. And now I have 99 is being divided by is dividing both sides. That cancels down to just n. So now I have 35 over 99. And let's do another. Let's say this here is let's say 0 and 126 thousandths. Well, not thousands, but 126 repeating. 3 places repeating. So first thing I do is set this equal to n. So n is equal to 0 and 126 repeating. It's 3 places repeating, so I multiply by 1000. Now I have 1000 n is equal to 126 and 126 repeating. I subtract those two values from each other. 1000 n minus n gives me 999 n. 126 and 126 repeating minus 126 repeating. The repeating parts go away, and I'm left with 126. Then to solve for n, I have to divide everything by 999. Those 999s cancel down to 1, or simplify down to 1. And I have 126 over the 999. But I see here I have a common factor of 3, because the sum of each one of these digits is divisible by 3. So that means I can divide the numerator by 3. And I know all these 9s are divisible by 3. Well, 3 goes into 12 4 times. 3 goes into 6 2 times. I can divide this here by 3. 3 goes into 9, so this is 3, 3, and 3. I can do division by 6 again, because 4 plus 2 is 6. Well, not by 6. I can divide by 3 again, because 4 plus 2 is 6. Well, 3 goes into 4 one time, giving me 1 left over. 3 goes into 12 4 times. And then 3 goes into 333 111 times. So my 3 equivalent fractions for these repeating decimals are 2/9, 35/99, and 14 over 100 and 111. And let's call up the calculator to verify these answers. Alright, with the calculator, the first one came out to be 2/9. So let's just do 2 divided by 9. And we see we have the repeating 2's. For the next response, it was 35 over 99. So 35 divided by 99. And we see that gave us the repeating 35. And then let's do the last one, which is 14 over 111. Let's do alpha and y equals. We want the first option just to be different here. The numerator is 14. The denominator is 111. Alright, notice that when I clicked enter, the calculator did not give me the decimal approximation. To force it to do that, click on math, press number 2 to get down to decimal, press enter, and you see now I have that 0 and 126 repeating. Alright, that solves it, or that sums it up for this video by STS. Please friend us on Facebook and also subscribe to that YouTube channel. And as always, thank you guys for watching.